And to spill the data contents into memory, we have to use a specific data structure which you are already familiar with called stacks. Okay, so how does stacks work? Mm-hmm. How does stack work?
I don't think they got to stacks yet. I don't think 3500 has gotten that far.
No, we put stacks in the
Say 2050.
Yeah, but you guys forgot heaps in 2050.
How does stacks work?
first and last out.
First in, last out, or last in, first out. So a stack needs pointer to point to the top of this stack. We discussed this, that how we can actually retrieve the top of this stack element. Okay, so which means that in order to retrieve the top of this stack, what are we actually looking for? How we can locate the top of this stack. The stack is in memory. Okay, how we can locate the top of this stack? We need to have an address which points to the top of this stack, and that address is stored in X2 register. It is reserved for X2 for stock. Oh, it's okay. So X2 actually is a stack pointer. I mistakenly have written pointer only, so kindly correct it in your reference sheet. X2 points to a stack pointer. Okay, so the reference sheet I have given it to you, it just says pointer. What operations we can perform? Push and pop operations. So push means pushing the data into a stack. Pop means retrieving the data out of this stack. Okay, and again remember, the stack grows from, okay, no, so memory instructions grows from lower to higher address. The stacks are implemented the other way around. The stack grows from higher to lower address. Okay, so for example, if we have a memory here, a stack is pointing to this location. So if we add a new element, instead of going up, it will grow downwards. Okay, so new element is added up here, let's say X20, whatever element that we have pushed in, and once we pop it out, okay, so before talking about the popping out, so how do we do that? So SP is reduced by -4. So again, instructions are going in upward directions. Okay, so the address of the instruction memory goes upward direction. So the first instruction is 0, next instruction is 4, and then 8, and so on and so forth. But if SP is pointing to this location, when you push an element into a stack, it means that a stack pointer should be updated, and it should grow in the downwards direction. So in order to grow, in order to push a value, you have to subtract by -4. Because when you subtract it, this pointer will come down and point to the location, point to the instruction which is 4 value less than the previous value. Understand? So whenever you have to push the element into a stack, you have to first, what do? Is you have to first decrease the SP value by 4 first, every time whenever you write a code. Okay, and then how do you push? You can use a store word instruction. The store word grabs the data from register and put it into the memory. Where are we putting it? With the address pointed by SP. Okay, so SP contains the address. And what is SP here? Where is the value of SP stored? I have just mentioned that in register number X2. X2 corresponds to SP or the stack pointer. Okay. What do you think when we perform the pop operation? What instructions do we need to use? What does pop do? Pop, yeah, takes the reads the element from top of this stack, which means that we have to, once we read the element, we need to also update the SP pointer, right? So first of all, you read. How do you read the contents from memory to register? We can read with the load word instruction. After loading the word from memory to register, we have to update the pointer SP with the help of this add I SP SP4. Here we have to first read the value and then update the SP. Okay, while pushing the value, we have to first update SP and then push the value, so that the new value, the top of this stack should be pointing to the updated value, the value at the top of this stack. Yep. Getting rid of what?
The top L.
We are not getting rid of anything. We are just, so how does the stack work? You can either push the element on the top of this stack or remove the element from the top of this stack, okay? So initially SP was pointing to this one, whatever, I don't know how many number of elements are there, but this is pointing to the top of this stack. If you have to push a new element, it will eventually become the top of this stack, right? So when you push a new element, you have to update the address of SP, stack pointer, which is pointing to the top of this stack, to the new instruction. Now this value is pointing to the top of this stack, okay? Similarly, when you have to pop the element out, so before popping the element out, you have to read the value and then update its SP, so that now new top of the element is this one, top of this stack, okay?